So before we get into scientific notation, what can help is to have kind of a base understanding of just powers of 10. So if we have 10 and then some exponent on it, what is that exponent doing? And really it's about moving a decimal around with these ones and zeros. So we just want to make sure that we know how that exponent affects our number. So what we're going to do is look at each of these numbers. So this would be called the decimal form. Sometimes even referred to as like regular form, would just be our numbers over here. And then exponential form is where we're going to change into base 10. So that's what we call that. That would be our base. And then we'll have some exponent on it. And that would make our exponential form. So with each of these, what I want to do is, in fact, I'll just go ahead and write these. I'm going to have base 10 for absolutely all of these. So I'm just going to go ahead and down the line, write 10. And then what I want to fill in the blank for is an exponent on 10. So with that, I'll need to look at the number that I'm dealing with. So for this first example, where it's just 10, the exponent that we would need on 10 is just a 1. If we have an exponent of 1, it just keeps the base as it is, and that would be it. Now for 100, what we would need to do is take 10 and multiply it to itself. So really what we're doing is we're taking 10 times 10, and for that means we need an exponent of 2. So again, exponents just multiply that base to itself, and the exponent tells us how many times we do that. If we have 1,000, that's coming from 10 times 10 times 10, which means we need an exponent of 3. What we could start to see here is there's a few different ways to think about it. The quickest way that I think of it is with these numbers where the zeros are trailing at the end here, the exponent matches the number of zeros. So with 10, we have 1 0, exponent 1. 100 has 2 zeros, exponent of 2. 3 zeros, exponent of 3. So with that, you can use that to tie it together. Something that we'll also talk about is kind of moving a decimal around. And when we think about our decimal, what we're going to do is think about the number 1 and then having a decimal. 1 decimal, 1 decimal. So if I needed to move that decimal to make 10, what it would look like is it would move to the right 1 spot. So moving to the right 1 leads to positive 1 exponent. With 100, we would need to go 1, 2, and fill in the blank with some zeros there. So that would be moving to the right 2 spots, which links to positive 2 exponent. And for 1,000, we would go 1, 2, 3, 0, 0, 0. So moving to the right 3 links to positive 3. So if we get to this one where we have lots of zeros, and I don't want to think of it as the breakdown of how many times am I multiplying 10 to itself, we have kind of 2 ways that we'll go with this. First off, you can just count the number of zeros. I have 6 trailing zeros there after the 1, so that tells me I'm going to have an exponent of 6. What you can also do is imagine that if this was 1 with a decimal right there, we would go 1, 2, 3, 4, 5, 6. So moving to the right 6 would give us an exponent of positive 6. Both of those ways work for these. I like to show this idea of moving the decimal around because that's going to help us a lot when we get to this next one, when we have decimal values. So this 0.1, this is the equivalent of 1/10. So I could even write that as 1/10. And what happens with decimals is it leads to negative exponents. So like having this be a 10 with a positive 1 exponent, since it's in a denominator, that would lead to a negative 1 exponent over here. You can think of it this way, but what we're going to more rely on is this idea of moving the decimal around. So if I had 1 and my decimal, in order to get 0.1 out, what I would do is move that decimal left 1 spot. And moving to the left 1 is going to lead to -1. So there's going to be this relationship of direction and positive versus negative. So these ones where we're moving to the right, it's positive. Moving to the left, negative. It's like for this one here, it's like if it was 1, we would have started there and then we went 1, 2. So because we moved to the left 2 spots, this would be -2. For this next one, if we had 1 with our decimal there, and we go 1, 2, 3, since it's left 3 units, it would be a -3 exponent. So when we get to a case like this, you'll see a decimal, and we'll go 1, 2, 3, 4, 5, 6. So because it's left 6, we would have -6. So with these, the idea is that if you have large whole numbers, that's going to come with a positive exponent. When you're dealing with decimals, you're going to have negative exponents coming through. And then it's just a matter of, if you think of 1 with a decimal, are you moving to the right? And if you are, how many spots are you moving? If you're moving to the left, how many spots? And that will determine the numerical value that shows up in that exponent.